These are for notes for dividing radicals and especially emphasizing on rationalizing. We're going to hear this term rationalize the denominator, and that means we want to get square roots out of the denominator. It's kind of a proper form, at least until you get to calculus and then they start to relax on some of those things. But you don't ever want to leave your answer with the square root in the denominator. And so a couple terms that are helpful: conjugate is not conjugate, it's conjugate. You realize the relationship radical 5 plus 2, the conjugate of that is radical 5 minus 2. The reason why, when you go to multiply these together, the inside and outside terms cancel out. And so you end up with just numbers. It's a way to get rid of the radicals. You'll see it later. And the most important thing is that 1 has many forms. It's not just 1. Radical 2 over 2, 5 minus radical 3 over 5. All of these are equal to 1. You can do them with different roots. So cubed root of 4 over the cubed root of 4. That's all those are equal to 1. And you can multiply anything by 1. That's why that's important. Okay, so I'm just going to go through a bunch of these notes kind of quickly here. Radical 9 over 49. Try rewriting it first. Use factors, perfect squares. That one's easy. Square root of 9 is 3. Square root of 49 is 7. It's always worth checking. Radical 10, radical 32. I know I got to get this out of here. There's a couple ways you can simplify this. You could simplify it using your properties we've been doing. So 32 breaks down into 16 and 2. So I know this is radical 10 over 4 radical 2. And then I could use my properties of radicals, and I know the 2 and the 10 can divide out, so I'd have radical 5 over 4. That method works. You can also just go right to it and multiply by radical 32 over radical 32. You could also factor. The other method would have been to take 5 and 2 and 2 and 16, and it cancels out. Either way, you get to this point. So sometimes it's trial and error. So I'm going to do the factoring thing here. 7 and 3. I'm left with radical 7. That is rationalized. You can have a radical, you just don't want it in the denominator. 4 radical 2 over 3 radical 8. I know that 2 goes in there, so I'm going to write 2. This says 2 and 4. So I have 4 over 3 times 2. So 2 goes in there 2 times, just 2/3. Simplified all the way. 5 over radical 2. Okay, so now we have one where we need to rationalize without using just our properties. We need to use our special 1. So we've already done this a little bit. I know that radical 2 times radical 2 is 2, so that's my 1 I want to use. I could use anything that makes this a perfect square, but you have to reduce later if you don't. So this is 5 radical 2. Radical 2 times radical 2 is 2. And that's your answer right there. Radical 2 over radical 7. Again, I don't worry about the numerator. I want to get rid of the denominator to rationalize it. Here's what some people want to do. They want to cancel out. Well, that takes you right back to where you started, so don't do that. You're doing this for a purpose. Radical 14 over 7. 5 radical 3 over 2 radical 5. Again, I'm not worried about the numerator, I'm worried about the denominator. So I'm going to multiply by radical 5 over radical 5. So that's 5 radical 15. 2 times 5 is 10. Sorry, some days when you stay too late, it's not. Radical 5 times radical 5 is radical 25, which is 5. So 2 times 5 is 10 that way. Sorry. 5 goes into 10 2 times. So you want to make sure you reduce the old-fashioned way at the end. Careful, sometimes 5 times 5 is the same as 5 plus 5 when you're tired. Alright, so you need to multiply by radical 3 over radical 3. You might want to just reduce this right now. So we have 4 times radical 2 times radical 3, which is 4 radical 6. Radical 3 times radical 3 is 3. Pretty straightforward on those. Now we get to what we talked about with the conjugate. So the problem is if I use this, if I don't use the conjugate down here, if I multiply by radical 5 over radical 5, I'll get rid of this one, I'll still have this one. I'll just keep going back and forth. It's like Pete and repeat sitting in a boat. Pete fell out. Who's left? Repeat. You never stop. So what we do is we change our 1. Our special 1 is now going to become the conjugate over the conjugate. Radical 5 plus 2 over radical 5 plus 2. Still equal to 1. Now I have to distribute here, so I get 3 radical 5 plus 6. And when I multiply these down here, I can distribute, and that's radical 5 times radical 5, which is 5. Radical 5 times 2 is 2 radical 5. Negative 2 radical 5. And negative 4. So what happens here is the 2 and the 2 go away. So I'm left with 3 radical 5 plus 6 over 5 minus 4, which is 1. So I just have 3 radical 5 plus 6. So the conjugate, if you pick it, you don't even have to worry about the middle term. You can just multiply the first and last terms. The middle term will go away. So conjugate here, 5 minus radical 7, 5 minus radical 7. So I distribute. So that's 5 radical 3 minus radical 21. And then down here, it's just 25 minus 7, because radical 7 times radical 7 is 7. Don't worry about the inside and outside. They're going to go away if you pick it right. So it's 5 radical 3 minus radical 21 over 18. Get a little crazy here. We got radical radicals. I'm going to write down here. So the conjugate would be radical 2 minus radical 5. Again, I'm multiplying by 1, which doesn't change the value, just changes the form. So 7 radical 2 minus 7 radical 5 over 2 minus 5. Means I have 7 radical 2, 7 radical 5 over negative 3. And you can split up, change form, whatever. I'm going to skip this one, same as the others. Okay, keep going. I'm going to rationalize. So this is where it gets a little tricky. I need to have a perfect cube down here. And so I got to pick whatever I multiply this by to get a perfect cube. Well, I have 1 5. I need 2 more. That's 25. So I need to multiply by cube root of 25. So when I do that, I get 2 cube root of 25 over cube root of 125. Looking on your chart or using your calculator, working backwards, that's equal to 5. We picked it that way. So you have 5 and 5 squared. So that's 2 cube root of 25 over 5. That's it. So I need 9 is not a perfect cube. 3 times 3 is 9. So I need another 3 to make it a perfect cube. So I'm going to multiply by cube root of 3 over cube root of 3. So 5 cube root of 3 over 3. We made it perfect. It's cube root of 27. Same here. We're rationalizing. We're ignoring the numerator. This is 2 times 2. And I want it to be 2 times 2 times 2. So I'm going to multiply it by 2, cube root of 2. So I have cubed root of 4. And this is going to be cubed root of 8, which we picked to just be 2. Last one. Thinking about 25 as 5 times 5. I wanted to have another 5 to make it 125 so I can take it out. So I get cubed root of 35. This is all equal to 5 because we picked it that way. Notice every time, every one of these, and go back through and check, are all equal to 1. When you multiplied by 1 all the way through here. 1 has many forms. Okay, your assignment is on the back of this paper. You have some simple rational, you have a few conjugates. Be careful with these fractions, see what you can do. And then I have a couple questions for you stinking thinkers. This is just like a fraction. How would you add 1/3 or subtract 1/3 and 1/2? What would you do? So how would you do that problem, and see if that helps you think about it. And then down here it says find x squared. When you read this question, find x squared. And then it says hence show that. Show that means plug it in and verify. They're telling you that this equals 0. Can you verify it? Very common IB question. Upper level thinking. Okay, that's it.